some kind of estimate when they are asking for financing.
Yeah, I think that fits something similar to what some companies are doing by doing an equal impact assessment, trying to quantify the impact of their work environmentally. So if we could do that in other ways.
Okay, let's move on. Thank you, Jessica, and thank you for. So we're now into lightning talk mode, and we have just going to talk about the antenna platform.
Yes, so I'm Anna, and I will talk about the tool we built called Antenna. So Antenna is an open source insect monitoring platform where ecologists and entomologists can collaborate with machine learning researchers and computer scientists to sync, process, and manage insect camera trap data. I can also say that the project is led by a group of researchers and engineers from Mila and Yale University with support from Space for Life Insectarium, and the ideas started some years back as part of the AMI group. What we noticed is that for automated insect monitoring, often we have people with different expertise involved in teams. For example, in a team, we might have research technicians who work more closely to the hardware. We might have machine learning researchers who work more on training models to process images collected. Then we have regional experts who can validate these machine predictions. We have ecological researchers who wants to use this data to study biodiversity trends. And we might even have decision policymakers who are perhaps more interested in the insights. And of course, not all teams looks like this. Sometimes maybe one person fills multiple roles, but that's just to give you an idea. And what we noticed is that multidisciplinary teams need tools to collaborate and to coordinate. And this is where Antenna fits in. Since the platform is web-based, we can have users contribute on different fronts, but still like work on the same monitoring project. So Antenna is project-based to help users keep data organized. One project can have one or many stations, and one station can be hooked up with the data source for camera trap images. Then you can process these images using one of the available pipelines on the platform, or you can bring your own. After processing, you can see where and when different species were observed, but the algorithms will not always get it correct. One important feature is that you can also invite experts to validate these predictions. And all the data can be exported, of course, for further analysis. Here are some screenshots just to give you a sneak peek. If you are interested to use Antenna, you can learn more on insectai.org. You can also come talk with me, of course. As I said, the code is open. We really need help, so you can also go check out our GitHub repository. Tomorrow, I will also host an interactive session where you can test this tool in practice. So feel free to join that. You don't need any programming skills. So you can bring your laptop and come as you are. And I also have some stickers and cards for fun, so I can give you that as well. Thank you.
Thank you, Anna. There's not very many stickers there.
I have more in my.
Any questions for Anna?
Yeah, I think the current is to be a big model. But
Yeah, is he?
yes, we do. And actually, like this year, we have got more resources to process data. We have built the system generic though, so you could hook it up with your own like service for processing. But the idea is also we want to make it easy for people to just get their images processed. We have capacity to do so, so we're excited. That with some limitations, of course, but yeah.
I think that the presentation factor is about the fact that the antenna provides species, but propose a name, but as per what the species name. Well, for instance, and that's right, propose a tree, or something that would be a possibility to propose maybe all the species will certain score and provide the names and picture of the potentially species.
And we do, it's a hidden feature, but for each prediction